Okay, this is starting chapter 11. Vocabulary should be first, measuring length and area, which is my just 2 pages. And then 53, probably through 55, possibly, area of triangles and parallelograms, 11.1. Okay, here you go. On page 53, notes 11.1, area of triangles and parallelograms. The first is the postulate 24. This is the formula that you should know. Area of square is a postulate. It says that it is a square of the length of the sides, right there. Okay. Then we have postulate 25 is the area congruency. It says 2 polygons are congruent, then they have the same area. They're congruent, then they have the same area. Okay. Postulate 26 is a reminder of the one we've had a lot of segment addition postulate and angle addition postulate. And it says area of addition postulate. The area of 2 regions is the sum of 2 areas of non-overlapping. So here it is, the sum of the areas will be the area of the big region. Okay, we have the first theorem for this section is the area of a rectangle. It is the one that you've seen before, which is area equals the base times the height. This says product, that means multiply. And we have also theorem 11.12 is the area of a parallelogram is the product of the base and its height as well. Same formula as the other theorem, it's just a parallelogram. Then we have theorem 11.3 is, okay, 11.3 theorem is the area of a triangle, which it says it's half the product of the base and its corresponding height. So it's this formula, but I will typically have this one, area equals BH divided by 2. This is what the ones I will always use, so it's easier to work with using math. Okay, our first examples are right here. It wants us to find the area of those polygons using those formulas we just had. So on the first one, this represents our base and the 12 represents the height, so our formula is base times height, which means that will be 15 times 12. I get my calculator, and 15 times 12 is 180, and there's not any units on this, so that means this is just units squared. I'll put UN for that, and that will represent your area. On number 2, this one is a parallelogram for this picture, which is the same formula that we've had, which is base times height, where the 24 is my base and then the height is the 12. And notice on a parallelogram it has to be the line that is perpendicular to the side. So to fill this one in, I'll have 24 times 12. If I do the math for that, that is 288 units squared, and since I don't have actual units, I put the UN to represent the units squared. Then number 3 is a triangle, and the formula for the triangle is the BH like it had before, but then I have to divide it by 2. If I'm looking at my picture, the 13 is the base and the 8 is my height, but remember this height has to be the perpendicular side. So if I fill it in, that means this is going to be 13 times 8 divided by 2. 13 times 8 is 104, and then I have to divide it by 2, which gives you 52 units squared, would be the area of your triangle. Alright, example number 4, it wants us to find the value of x, and on this problem they actually give you the area already, and then we have this particular shape given to us. Realize this is a triangle, and since we're dealing with a triangle, the formula will be the BH divided by 2, because it's a triangle, it's half of a rectangle. If I'm identifying it, the base here is just the 10, and the x represents my height because it's the perpendicular side, and the 25 is extra. We don't even need the 25 for this problem. It's just extra showing us information. So if I fill in my formula, I have the area is given to me, so that means I have 70 is equal to the base, that is 10, the height is x, and then I have to divide it by 2. One way to work this is to go ahead and divide 2 into 10 and get 5x equals 70, and then divide by 5. 70 divided by 5 comes out to be 14. And since this has units, that means this is 14 centimeters for the value of x. Okay, example 5. Notice they don't give me a picture, but they said find the perimeter and area, so we have two things we have to find for a triangle. Now this says hypotenuse. Hypotenuse is a big clue that our triangle is a right triangle, because a hypotenuse is always opposite the right angle, that is 17 feet. The leg is 8 feet. I'm going to put the leg standing up on the side. I have to find out the base. Okay, that's a question. And since I have a right triangle, that means I have only one option to use, which is a squared plus b squared equals c squared. Hopefully you remember this guy's name was the Pythagorean theorem. Now, looking at my sides, the base will be the b, a will be 8, and that means c will be 17. So I'm going to do 8 squared plus the b squared is equal to 17 squared. That gives me 64 squared, and 17 squared is 289. I'm going to subtract 64. B squared is equal to 225. Then to find b, I'm going to take the square root of 225. Use my calculator. That tells me b is 15 feet. Okay. Now, if I go back to it, the perimeter, is what I'm asked to find. So remember, perimeter is the distance around a shape. So that means I'm going to do 8 plus 15 plus 17 plus 17. And that gives me 40 feet is my perimeter. And then the area of a triangle is BH divided by 2. The B is 15. The H was 8, and I need to divide it by 2. Okay, 15 times 8 is 120, and cut that in half means this is 60 feet squared is your area. Alright, example 6 wants to know what's the area of the quadrilateral. Well, if I'm looking at this picture, this quadrilateral, I can actually see it as two triangles. I'm going to draw a line across here, is the triangles I see. and then there's a line here. I see this top triangle has a base of 1, 2, 3, 4 and a height of 1. So to find the area of triangle BCD, I'm going to do base times height divided by 2, which the base is 4, the height is 1, and divide by 2. That gives me 4 over 2, which is 2. Now if I look at it going the other direction, the base is still 4, but now my height is 1, 2, 3, 4 as well. So for triangle ABD, using base times height divided by 2, we'll say the base is 4, the height is 4, and then divide by 2. That's 16 over 2, which is 8. So for the quadrilateral ABCD, the area is those two things added together, which is 10 units squared. If I look at number 7, I want to find the area of the shaded region. If I'm looking at this particular shape, I see a rectangle. If I put letters on here to A, B, C, and D, and I could place E right there in the center. If I find the area of the rectangle A, B, C, D, I'm going to do base times height, which the base is 34 and my height is 21. So to find the area of this section, I'm going to multiply 34 times 21. That gives me 714 units squared. Okay. Now I have this triangle. Triangle ADE. The formula is base times height divided by 2. I know this side is 16. Since BC is 34, that means AD is also 34. Notice I have a right triangle, so that I'm needing to know this height here. You know what that height is. And since I have a right triangle, like before, if I had a right triangle, I had to go back to Pythagorean theorem to find the side. If I look at these numbers, down here below it, I'm going to make the 16 my base. That'll be my A side, which will be my height. And the 34 is always going to be the C because it's across from the right angle and it is the longest side. So I'm going to take 16 squared plus A squared is equal to 34 squared. 16 squared is 256. 34 squared is 1156. I'm going to subtract 256. Gives you 900. And then square root of 900, I believe, is 30. That means this side, ED, is 30. I did all that work so that now I can say this is the height of my triangle, 16 being the base for my formula. 16 times the height of 30 divided by 2. 16 times 30 is 140. I want to divide that by 2. That gives me 240 units squared. Now, they want to know the shaded region. Okay, the very important shaded. The 714 is the entire rectangle. But notice the triangle is white. It is not shaded. So that means these two numbers, I got to do something with them. Can you guess what it's going to be? Okay. Area is going to be the 714 minus 240. 714 minus 240 leaves this as 747 units squared is my final answer for my area. Okay. The independent practice in this section I'm going to leave for you to work, and I'll put the answers up in the classroom to see if you get them correct, to check your work this time. So here we go. The first independent practice is this one. I want you to find the value of x using this area, 16 being your base, x being the height. Independent practice number 2 is like our example. I believe it was number 4. Nope, number 5. Example similar to example 5. Give you a hypotenuse of 53 and a leg of 45. It is a right triangle because of the hypotenuse. Find perimeter and area. Independent practice number 3 says find the area of the quadrilateral. Here you can tell the base is going to be 3, but you have to find your height of this side. Find your height. You can draw a line from B straight up to find your height, or from D straight down to find your height. Independent practice number 4, we have an arrow here. They want you to find the area of the shaded region. And then number 5 says that in the quadrilateral ABCD, AB is a base. That's 25 units, and AB is 12 units. So when you draw your picture, you'll be able to label those two sides. They want you to find the height and the area of the triangle ABCD if one of the angles A is 30 degrees. Well, that one's tricky. That one requires you to use some trig from our right triangles chapter. Make sure you work these, and I'll have the answers posted in class tomorrow or on the day that these are due, and we'll check to see if you did them right.